Hola. Today we'll be looking at surds and rationalization. Many students find surds and rationalization confusing when fractions are involved. In this lesson, I'll show you a simple step-by-step method to understand and solve rationalization. Don't worry if this feels a little difficult, but I'll break it down for you. Before we look at and define what are surds, let's look at some properties of surds. So let's look at some properties of surds. Surds says that 1 square root of a times square root of b is equals to square root of ab. 2 square root of a divided by square root of b is equals to square root of a divided by b. And 3 is square root of a times square root of b, or square root of a times square root of a is equals to square root of a squared, and that cancels out. That is a. These are some properties of surds that we would need inside, and also we would need fractions, since sometimes fractions are involved. So we'll need fractions, properties of fractions, a over b times c over d. Since a fraction times a fraction, we'll multiply numerator with numerator and denominator with denominator. So that is a over c over b times d. These are some properties that we will use inside when we are solving surds or rationalization. Let's look at part 1. Let's define what are surds. Now let's start with what is surds. Surds is a square root that cannot be simplified into a whole number. Let's look at one example. Examples are square root of 2, square root of 3, square root of 5, and goes on. These stays as square root form. We cannot convert these numbers into a whole number. So these are called surds. Let's look at part 2. Simplifying surds. Now let's simplify surds step by step. Let's look at one example. Let's say square root of 12. Now when we solve square root of 12, we need to look at a perfect square inside 12. So if I break 12 apart, a perfect square inside 12 is 4, because 4 times 3 gives me 12. So the perfect square inside 12 is 4. So that means I can multiply 4 times 3 gives me 12. So I'll obey this formula. So I'll say square root of 4 times square root of 3 is equals to square root of 4 times 3, which is 12. So square root of 4 times 3 is 12. Square root of 12 is equals to square root of 4 times square root of 3. But what is square root of 4? We know square root of 4 is 2 times square root of 3. So a times b, a times b is equals to ab. So 2 square root of 3 is 2 root 3 is equals to square root of 12. So we can say that square root of 12 is equal to 2 root 3. These mostly exam type questions where they ask us to simplify surds, and whenever we simplify we need to first look at a square number inside that particular surds. In our case is 12, and the square number inside 12 is 4. So that means when we take a square root of 12, or sorry, square root of 4, it gives us a whole number. Let's look at part 3 of the question. So part 3, we can say that we go on to rationalization. So suppose we have 1 square root of 2. We rationalize 1 square root of 2. Now how can we rationalize this function? Now in rationalizing this, rationalization or rationalize, to rationalize is basically taking the square root of the denominator out. And how can we do that? We multiply this by the square root. So I want to take the square root out from here, so I'll do this. 1 over square root of 2 times it with square root of 2 over square root of 2, because I want to take the square root out of the denominator. That's the whole purpose of rationalizing. Whenever we're rationalizing, we're basically taking the root out of the denominator. So we multiply with the square root. So what do we understand about a fraction times a fraction? Fraction times a fraction, we multiply straight. So we multiply straight. 1 times root 2 is 1 root 2, or we can say root 2 over root 2 times root 2. So root 2 times root 2 is root 2 squared. These 2 cancels out. So we can say that this is root 2 over 2. So we can say that therefore 1 over square root of 2 is also equal to square root of 2 over 2. And that's your answer. That's how we rationalize the rationalized functions. Let's look at part 4. We normally call it a slightly harder example where we try and factorize. Example, let's say 3 over root 2, or we can say a conjugate. So we can say that this is 3 over 2 root 5, a little bit higher, or a little bit higher or harder. So how can we solve this? Concept is the same. I want to get rid of the denominator, so this is 3 over 2 root 5 multiplied by the square root function, which is square root of 5 over square root of 5. So a fraction times a fraction, we multiply straight. So this is 3 square root of 5 over 2 square root of 5 times square root of 5 is square root of 5 squared. So this is 3 square root of 5 over, these 2 cancels out, so you're left with 2 and 5. So 2 into 5, so that is 3 square root of 5 over 2 times 5 is 10. So we can say that therefore 3 square root over 2 root 5 is equal to 3 square root of 5 over 10. Now the last part is factorize, solving with conjugate, or rationalizing with the conjugate. So whenever we're on to the conjugate, this is mostly exam type questions. Let's look at one example. Let's say 1 over 3 plus root 2. We need to rationalize this function. And how can we rationalize? We rationalize this function by multiplying this function with the conjugate of the denominator. So our denominator is this function. We want to multiply with a conjugate. Conjugate meaning the opposite of plus is minus. So the opposite of plus is minus. The function remains the same, but only the sign changes. Just like you lifting your hands in the mirror. When you stand in the mirror, you look at yourself, but the difference is when you lift up your right hand, the image is lifting the left hand. So the image in the mirror is your conjugate. Similar case here. So this is a function, you're multiplying with a conjugate. So this is plus, then you multiply with a minus. So that is the conjugate of 3 plus square root of 2. So 3 plus minus square root of 2. Now let's simplify. Fraction times a fraction, we multiply straight. So 1 times 3 square root of 2 is 3 minus square root of 2 into 3 plus square root of 2 over into 3 minus square root of 2. Now you can take a time to pause and try and open this up, and then you can solve them, and then we can see how it goes. You can pause and try this up on the denominator and try and open the bracket. Okay, let's open it. So this is 3 minus square root of 2 over 3 plus square root of 2 into 3 minus square root of 2. So we'll try and open the bracket. This one goes here. Whenever we open the bracket, we'll also obey this sign. Sorry. Positive times positive is positive. Negative times a negative is positive. The difference is when I multiply the two. Positive times a negative will give me a negative. We'll apply it here whenever we open the bracket. So let's open it. So this is 3 minus square root of 2 over 3 times 3 is 9. I want to go here, but I'll go through the sign. So positive here, positive, whenever you open the bracket, you times. So positive times negative is negative. 3 times root 2 is 3 root 2. This one goes here. Positive times positive is positive. Root 2 times 3 is 3 root 2. This one goes here. Positive times negative is negative. Root 2 times root 2 is root 2 squared. Now, something that you need to notice, that these two will cancel out. Not only that, these two also will cancel out. So you're left with 3 minus square root of 2 over 9. These two cancels out, minus remains minus, and the number here is 2. So I can further simplify that. This is 3 minus square root of 2 over 9 minus 2 is 7. So this is your answer. If this helps you, I've created a worksheet with step-by-step solution to help you with your practice. You'll find the link in the description. And if you want more lessons like this, you can check out more of my channels on level mathematics. We'll stop over there. Thank you.